So we are starting chapter 6, which is Trig Identities. We're going to start with the 8 fundamental identities, and just a few things you should know before we start. So an equation is a statement of equalities that can be satisfied by 1, 2, or more values of a variable. Okay? An identity is an equation where that is satisfied by all values. So basically, you guys, an equation like 2x equals 4 would have one answer. Some equations have 2 answers or a few answers. It depends on the kind of equation. Okay? But an identity is an equation that's always true for every x. So an identity is where you could plug in any x you wanted and the equation would be true. Okay? Now a trig identity is an identity, so something that's always true, but with trig in it. So sine, cos, tan, cosecant, secant, and cotan. So these are the 8 fundamental identities. You can take a read through them. These are all on your formula sheet, so they don't need to be memorized. So for this one, we know that tan is sine divided by cos, and we know that sine is 0.7986, and cos is 0.6018. And when I divide those two numbers out, you should get 1.3, yeah. 3270. So for example 2, to show that identity works for any value of theta, I'm just going to say that theta equals 17 degrees. Okay? You could say any number you want. So we could take sine squared, or sine 17 squared, and add that to cos 17 squared. And just by calculating that on your calculator, give it a try, but it should equal 1. So here in example 3, it says if tan is minus 4 over 5 in quadrant 2, find the value of cosecant. So if I look back to my identities here, is there an identity where both tan and cosecant are in it? So this one doesn't have tan and cosecant, but it does have cotan and cosecant. So I can easily change tan to cotan and then use that identity to find cosecant. So here again is the question. So we know tan theta is negative 4 over 5. That means cotan theta would be negative 5 over 4, because you would flip tan into its reciprocal. Now our identity is that 1 plus cotan squared theta equals cosecant squared theta. You guys, the squared goes before the theta, but what this actually means is that cotan theta is squared. So you actually take the whole value for cotan and then square it. So we have that cotan is the minus 5 over 4. So that's the value that I'd square to get cosecant. Okay? So when I square this, I'm going to get 25 over 16. And before I can add 2 fractions, what do we need? Common denominator. So that means this 1 would actually be like 16 over 16, right? If we get them both to have a denominator of 16. So we add them and we get 41 over 16 equals cosecant squared. But I don't want cosecant squared, I want cosecant. So how do I undo the squared? Square root, exactly. Just like you would normally, we would square root both sides. So my answer is going to be square root of 41 divided by 4, because 41 does not square root nicely, so I'm going to leave it under the root, but 16 does square root nicely, so I'm going to root it to get 4. Now, we have to be careful with one more thing. It tells us that this is in quadrant 2. Now, in quadrant 2, according to a smart trig class, sine is positive, but the reciprocal of sine is cosecant. So this answer that we got has to be a positive. So just double check that. If it was in a different quadrant, it might have to be a negative. But in quadrant 2, cosecant is positive. So most of our questions in this stuff is going to be proving. So this one says prove that cos squared plus sine squared plus tan squared equals secant squared. Now there's a couple little rules. First of all, you can only change one side of the equation when you're doing proof. So the easiest thing to do, you guys, is to change the more complicated side. Because it's really it's easier to take a complicated question and simplify it than to take something simple and try to complicate it. Okay, so we're going to take the more complicated side here of the question and keep going until I get secant squared as an answer. Now, when you're doing this question, you think, is there anything I can simplify? Is there anything I can change? And I did put a green box around this part, because does that part look familiar? Cos squared plus sine squared. It equals what? 1, right, look right here. Cos squared plus sine squared equals 1. So if you look at your identity sheet, that means that I can trade 1 instead of having cos squared plus sine squared. So that means my next step would be 1 plus tan squared equals secant squared. So again, I just traded the cos squared plus sine squared for 1. Now let's go back to our identity sheet. Does 1 plus tan squared, does that look familiar? 1 plus tan squared. Okay, 1 plus tan squared, yeah, it's right here. What does 1 plus tan squared equal? Secant squared, right. So that means now I can trade secant squared for 1 plus tan squared. So I'm going to trade 1 plus tan squared for secant squared. And now both sides of my proof are equal. So that's how I know I've come to my right answer. When one side equals the other side, the proof has been made. Now you always end a proof by either putting a little square to show that you're done, or you write something called QED. Now QED is this really long Greek or Latin word that basically means the end. So you think of this as like your little celebration at the end of your question. It's like, yes, I got it right, QED. Okay, so here for our next proof, cotan theta minus 1 squared equals cosecant squared theta minus 2 cotan theta. I am going to start with this side, and it does not look familiar yet on our identities. But when something is squared, like let's say you had x minus 2 squared, what would you do to expand that? Right, you'd go x minus 2 times x minus 2 and you'd FOIL it. Same thing here. So actually, whenever you see that something is squared on the outside of a bracket like that, you can say that this is cotan minus 1 times cotan minus 1. Another little shortcut is that instead of writing the whole cosecant squared minus 2 cotan theta over and over again, you can say equals RHS, which means right-hand side. So sometimes these questions are so long that it's tedious to rewrite the other side all the time. So we'll just say equals our right-hand side. Okay. Now here, I can FOIL this out. So cotan times cotan is cotan squared. Cotan times minus 1 is minus 1 cotan. We have another minus 1 cotan. And then we have plus 1, because minus 1 and minus 1 is positive 1. Now I also see that there's something I can combine. Just like when you're FOILing anything, the two middle terms should be like terms, so you can add them together. So here we're sitting at cotan squared minus 2 cotan theta plus 1, and that equals the right-hand side. So we should notice here that the minus 2 cotan is already in the right-hand side, so that's good. So that just means somehow the cotan squared and the plus 1 need to give us cosecant squared. So if we look back to our identity sheet, I see that cotan plus 1 does equal cosecant. So in my final step of the proof, I'm just going to trade the cotan and the plus 1 for a cosecant. So we get cosecant squared minus 2 cotan theta equals the right-hand side. And that would be the proof, QED, the end. All right, so here for example 6, we have cos squared plus tan times sine equals secant. So I'd like you to start by writing this little hint down. All right, so let's look at our more complicated side here. I see that I have tan, and we can change tan into sine over cos. So I'm going to start by taking tan and saying that that's sine theta over cos theta, and that's also multiplied by another sine theta, and that's going to equal the right-hand side, or secant. Okay, so in this case, it's no quicker to say right-hand side than secant. Now, sine times sine, what does that give us?
Sine squared.
Sine squared, right? So we're going to get cos squared plus sine squared over cos. And that's going to equal secant. Okay. Now, I'm adding here. But I'm adding two fractions. What do you need if you add fractions? A common denominator, right. So I can't add these together unless I have a common denominator. So on this side, I'm actually going to multiply by cos over cos so that I have a common denominator so I can add them. So here, on this side, sorry, cos over cos, yeah. Okay, I have a typo here on your sheet in my example. This is not supposed to be squared at the start. Okay, so just get rid of that little squared, and then we can keep going. So now on the top, we'll get cos times cos, which is cos squared. And on the bottom, we'll get cos, and then plus sine squared over cos. So if I add them together, we get cos squared plus sine squared on the top over cos on the bottom. And remember, we're trying to get secant. So is there anything here that looks familiar?
Cos plus sine.
Right, cos squared plus sine squared equals 1. So I'm going to trade cos squared plus sine squared, and I get 1 over cos. Now 1 over cos, does that look familiar? What is 1 over cos?
Secant.
Secant, right. So that means that we get secant equals secant, which is QED, the end. Okay, so on top we've got cosecant squared, on the bottom we have 1 plus tan squared, and we're trying to get cotan squared. Start with, is there anything here that looks familiar?
1 plus tan squared.
1 plus tan squared. Okay, if I look to my sheet here, 1 plus tan squared is secant squared. So let's trade 1 plus tan squared. We'll trade that for secant squared. Good, so 1 plus tan is secant from our identity sheet. So now I've got cosecant over secant. This is kind of a tricky spot, but remember, if you're ever stuck, change things into sine and cosine. So I know secant is the same as 1 over sine, and secant squared would be the same then as 1 over sine squared. So I'm going to change secant squared into 1 over sine squared, and I'm going to change, cosecant into 1 over sine squared. Then I'm going to change secant squared into 1 over cos squared. Now when you divide two fractions, what do? You flip the bottom and then you multiply. So remember that what this means is that we have 1 over sine squared multiplied by cos squared over 1. So you'd flip the bottom before you multiply, just like always with fractions. So then fractions, top times top, bottom times bottom. So we end up with cos squared over sine squared. And does this look familiar? Cos squared over sine squared? Or cos over sine?
It's already finished.
Cos over sine is cotan. So I can finish this by saying, well, cos squared over sine squared is cotan squared, which is what I was trying to get. So QED, that one is finished. We're going to then do the handout questions on the back of your worksheet for our assignment today.